going to be two sections. When I'm done, he's going to continue and finish up. So we're talking about two things: getting for failure and security. Yeah, please. Let's go. Okay. I'm just going to share from the little knowledge I have. Very little knowledge, please. Okay. How many of us have seen this before? Have you seen this before? Silicon Valley. Okay. It's your infrastructure. No, it's my infrastructure, it's your code. Yeah. So I'm going to talk about reliability as because this is the core of failure. Google will say SRE implements DevOps. What does it mean? SRE is a subsection of DevOps, okay? Now, SRE engineers in Google are particularly developers who do operations. Someone was asking about developers. Do you have to be a developer to be DevOps and all that and all that and all that? The truth is, from my experience, it's a good to have. It's not compulsory. But when you want to step into this role, I mean, software engineering is very key. Okay, when you do SRE, you are like a software engineer that understands operations, because in Google, when things break in production, it is actually the SRE guys that fixed it, not even the software engineers. So it means that they understand the code, they know how the code works, they also understand infrastructure architecture and failure. Okay. I just want to clear that distinction, first of all, between SRE and DevOps. So where SRE talks about operations, DevOps talks about delivery. When SRE is talking about incident response, DevOps is talking about release automation. So most times, DevOps hardly thinks about failure. At least I don't say they don't. They hardly think about failure. They think about getting things fast. Okay, when things break, you just fix them and all that. But SRE is looking more of bringing the guy who is infrastructure, bringing developers together and say, hey, I have to be between you guys to ensure that systems don't fail. And when they fail, how do I fix them to ensure they come back up? Post-mortem, whenever a failure happens, what are the lessons we need to learn from that failure? Monitoring events and other things. Capacity planning, primary focus is what on reliability. While primary focus for someone in DevOps is what? Delivery speed. So for SRE, his own is about system of time, paramount. For the person in DevOps, see, if you notice 90% of DevOps will talk about pipeline. So it's mostly about deliver fast. But the SRE guy says, you can deliver fast, but how do we deliver fast without breaking things? Okay? Anything that can go wrong will go wrong. This is Murphy's law. Okay? I heard someone asking about the whole availability zone going down. I mean, it has happened, but I will not mention names actually. Yeah, it happened in South Africa, but I'm not going to mention the cloud provider. It was a big problem. Go and do your research. I will call the name. It actually happened to a cloud provider actually in South Africa. They were coming up and they went down for that week. So it can happen, actually. It was terrible. And the other people were like, see you guys are down. Woo! So it was very funny. Yeah, so anything that can go wrong actually. Yeah, let's put it at the back of our mind. So what are the triggers of failure? What are the things that can make your system fail? You need to take note of them. So the first thing is poor application architecture. Someone talked about architecture initially. So please, let's put architecture at the back of our mind every single time. The way you design your system is the beginning and the end of everything. If your architecture is poor, your system will be poor, your application will fail. Architecture here talks about code architecture, infrastructure architecture, reliability architecture, failover architecture, deployment architecture, every single thing, beginning to end. Security breach, okay, which can happen anytime, any day, okay. Poor infrastructure design, I repeated myself from the back. And then no incident management policy. So the organizations you go to, when there's a failure, that's when you see fire on the mountain, everybody's running up and down. Why? Because there's no incident management policy or structure. If you have an incident management policy or structure, all you need to do is, if you have it at the bottom of your head, you follow the process. If you don't have it, you go back to the document. Now, the good thing about documentation, which is very important, if you go back to principles like the well-architected framework, performance efficiency, or operational excellence. It talks about runbooks and playbooks. Now, what's the advantage of that? You can document a policy today and leave an organization. What do you leave the other people with? No knowledge. Okay, if you don't document, but when you have a documented policy, people can always go back to that policy and follow the process to ensure they mitigate that particular problem. So that's where incident management policies are very key, very important. Capacity planning failure. This is a very crucial problem too. So capacity planning in the cloud is usually very difficult. But to some extent, you need to remember at the bottom of your mind, when my colleague David was talking about scaling at OP, I'm sure capacity planning was part of the things he thought about. And then, I think we did not think about it properly, they saw what happened. You understand? So, they assumed that 1 million would be okay for 1,000. But look at what happened. So, to some extent, you need to have capacity planning as part of the goal, part of the things you design. Because if you don't, your systems will fail. I mean, it's very, very, very clear. Deployment of faulty artifacts. This also happens a lot. Okay, your testers have done their load test, everything is okay, it's all green, and then you deploy for some reason, it's breaking. I don't know if anybody has experienced that before. It just breaks. I mean, test environment shows green, but you get to production, failure. So, you need to look more at your deployment process. Okay, to ensure that this kind of thing doesn't happen. Okay, so I'm going to talk about Synfix architecture a little bit, so infrastructure. So Synfix runs on a hybrid cloud environment. We use various cloud providers. We have a mesh of on-prem and cloud infrastructure. We run about 70 to 100 deploys every single day across all the platforms. We use a lot of Windows and Linux servers, depending on the kind of products or service we are deploying. And we use AWS public cloud a lot. We use a lot of AWS and some form of Azure. So how do we architect for failure at Synfix? So trying to bring from the knowledge from what we've learned to us so that we see how we do that. So we have a very structured incident management framework that helps us to manage incidents when they occur. So we have first level support, second level support, and third level support when there are incidents. And then a whole lot of things that goes with the incident management framework that helps us to manage incidents when they occur. The next thing is that we have efficient logging and monitoring from application to server logs. Verilog to the rescue again. So we do a lot of Verilog. It helps a lot with gathering of metrics and understanding the systems in production, even in staging, anywhere it is. We can gather lots from applications, from servers, and that helps us to understand the system. Blueprint deployment to reduce failure on production. So this is a very good strategy to help you avoid failed artifacts. Okay? So if there's an artifact that fails, if you do blueprint approach to your deployment, you will find out. So you don't rule that out for the public. Okay? So during the blueprint approach, you have your blue, you have your green app. You turn off one, you switch on the other one, allow traffic to go there. When there's a failure, you can easily switch back to your old artifact and undeploy what you have until the issue is fixed before you redeploy. So Blueprint is one of the things we use a lot. I mean across our products, right? Across everything, actually, we do Blueprint very well. Proper release management strategy and tags. Now, this is very good for version control. I'm so happy when David talked about release management. And I think that's one of the major things that has made OPD successful. Now, release management is something that a lot of people don't think about. Everybody thinks about deployment, but releases is something that nobody thinks about. There's a whole strategy around how you release softwares. Versioning, tagging. Because if your release strategy is terrible, roll back. Trust me, do not know where to roll back to. You can't. Okay? But if you're tagging from your code level to your image level is clear, when you're rolling back, you know what you're taking to roll back. You have the release candidates that deploy successfully and roll back easily to it. So that's something else that we do that has helped us so far. Frequent system audits. I'm very big on this. Actually, audit every single thing as much as possible. Down to the network layer to find out what's going on. Autoscaling and Kubernetes to help failover. So this also helps a lot. we do auto scaling, we do failover. Kubernetes, we all know Kubernetes helps you with, when your pod dies, it comes back and all that. So we leverage on that a lot. And then DRSM for all applications and databases. So someone was talking about disaster recovery being difficult and all that. The truth is, it's better to have something than to have nothing. So your disaster recovery strategy might not be like that of a bank or that of a telco, but you should have something, okay? And it's something when everything goes down, what's going to happen? You need to answer those questions. And as you answer them year on year, you continue to build that disaster strategy. It's not going to be a 2-month job, it's not a 1-month job, it's not a 6-month job, it's not a 1-year job. Okay? As disasters continue to occur, you continue to update your disaster recovery strategy, and over time you grow and become better at this. So this is actually very, very core. So things like remote site backup are things we do. Things like having what we call active-active and active-passive DRO recovery. I cannot go into details now. I can always talk about it later. My colleague is also here to can give more details on it. At this point in time, I'll call on Livinus Enoja to continue. Thank you.
Good afternoon, guys. Say my name, and my name is Livinus Enoja. Let me just say it again. So he has taken care of, there's a whole lot of talk about, DevOps, and all that. And he has been able to, try to differentiate between the SRE and the DevOps. So, and earlier we also had the talk on the security part of, bringing security to DevOps. So here I'm also going to buttress a little on that, but me, I'm going to focus on the approach. How, if you want to bring in security into DevOps in your organization, what are the approach that you need to adopt to make that thing happen? So, just like the talk has been, what is DevOps? You all know what DevOps is meant to achieve. It's meant to marry the operation and engineering team together to ensure that they all get solution delivered as fast as possible. Apart from that, it was, democratic, responsible focus on providing the end user with a consistent experience. Of course, you wouldn't want your customers that are using your application to have a poor experience or to know that you are even doing anything at all. So it's also part of DevOps responsibility to ensure that such kind of incidents doesn't happen. It unlocks tremendous skills in product development and delivery. It's uptime improved, usage increase, and turnaround shortened. DevOps mindsets like Agile improves. Companies should think about security. That's the point. That's what I'm here to talk about. Yes, we all know what DevOps is supposed to give us as a company, make us deliver solutions faster. But we need to bring in security into it. This is expected actually. This is a high performance DevOps team. A typical high performance DevOps team in an organization. These are things that we expect. We expect that we have at least 50% less time in creating security issues. 22% less time on planned work. Especially, in an organization where you have a whole lot of unplanned work coming around all the time. You are supposed to automate a whole lot of things. Any work that is actually springing up almost every time and all that, find a way to make it automatic to ensure that it doesn't happen that frequently anymore. So the focus here is DevSecOps actually. This term has been explained earlier, what DevSecOps means. In summary, it's just bringing in security into DevOps. Security, it's in some organizations, they have the security units, they have the DevOps unit, they have the other units. But the point is, security alone cannot work in your life. In an organization where you have only security and what they do is to just scan infrastructure, make sure that your applications are not hacked and all kind of stuff. Security cannot function in silos. Security in an organization cannot function in silos. They must work very closely with the DevOps team. That is in an organization where they are different. But in some organizations where they are not different, they have to actually work closely. For the DevOps team that doesn't have any security units, you need to consider security very, very important. Adopting DevOps culture. What do we need to do as DevOps, as in an organization to adopt the DevOps culture? Just as I mentioned earlier, you need to track everything, security-wise. I'm talking about security here. You must track everything. Every asset or instance needs to be tracked and constantly updated. Avoid making things too difficult to track. There are some people in our organization where, when people are creating infrastructure, you see there's a demand from the business guy, or maybe from the developer. I want to test this particular tool, I want to do this particular deployment. Can you please help me bring up the server? And one DevOps guy or one infrastructure guy somewhere just goes and bring up a server without letting everybody know that the server exists. You need to be sure that you can track everything that is very, very important. That needs to be up at all times. Identify where you can simplify your security operations. It's very important too. Yes, we are advocating security into DevOps, security into DevOps processes and all that. But you need to know where to bring in security into the DevOps pipeline. Inventory your assets. You must know where your assets lies. All your servers, especially if you are a company like us that runs a hybrid architecture, where you can be using Azure, you can be using AWS and all that. You need to know where each server is at this point in time. Find a balanced alerting solution. This is very important. Alerting solution in the sense that you want to know whenever any security incident occurs in your infrastructure environment. You need to get a balanced alerting solution. In Simfix, we use a whole lot of alerting solutions, a lot of a strategy to achieve that particular stage. So what we do is normally for the monitoring, we normally ride on Nigis, and we connect it to an email in such a way that whenever anything goes down, we know their email. We also had it integrated to Slack. Whenever anything happens in that environment, you can also be notified via Slack. So the point is that your team has to be aware of what is happening at all times, especially when it has to do with security. To leverage power of the crowd. Power of the crowd. By power of the crowd, I mean, like, you don't have to say, okay, we are DevOps, and you leave the developers. You don't know anything about security. You need to leverage that. You need to proactive security operation is very, very important. Federate responsibility to users, not just security. For instance, even your users of your app and all that, you need to give them that sense of security for your own applications. Make them understand that their username, their password are actually in their hands. And if they don't keep it very well, people can actually use that particular means to actually get access into the application and do a lot of havoc. So you need to let them know, understand that they are also part of, that they also feel part of the responsibility to securing the application. Share knowledge of security and threats rather than hide them. Some people, when they notice vulnerability, especially those of us in infrastructure environment, and they notice a vulnerability in their infrastructure, a vulnerability in their application, for instance, they don't share it. They find a way to let's see how we can mitigate it very fast without anybody knowing it. It's good to share it with your development team, share it with your organization, so that everybody knows what is at stake. Every code, everything is good nowadays, including security and infrastructure, leveraging them of course, infrastructure as a code. Not every tool outside there can just be adopted. There are some things you want to achieve security-wise that you might need to actually code out yourself. Have a public bug bounty. It's very important. This particular aspect also, public bug bounty. More like, giving your application out and stating very clearly to the public that if anybody can have a will to hack into your application, they should approach you. It will help you strengthen and know your weaknesses, especially when it comes to securing your application. So if you have a public bounty, it's very, very important. So anybody that succeeds in that regard, of course, you have a reward for that person. It will help you also strengthen your security architecture. Lean heavily on automation. Just like we mentioned, DevOps is all about automation. So when it comes to also security, if you're integrating security into DevOps, you also need to automate a whole lot of things. like checking, scanning your servers. If you want to scan your server, you can actually automate it and make it scan like periodically. Let's say every week I want an automated scan. Let me scan across all my servers, tell me all the vulnerabilities that are available. And you can also automate it in such a way that you can even, when it detects, let it fit or create an automation that runs patch across. It's very, very important. Build products that are secure by design. This one is very, very important. Especially the best time to secure a product is actually during the design stage. Most times, some organizations, what they do is that when they are designing the application, they normally don't carry the DevOps along, and they normally don't carry the security guys along. It is very, very wrong. Because it's good that when you are even designing the flow of the application and all that, it's very important that the DevOps and the security guys are aware and involved in that particular stage to ensure that the application stays very secure. So do threat modeling. There's something we call the threat modeling for every application. Security consideration, you make sure that every task that comes around the development of the application has a security part attached to it, such that you have to consider every feature and consider the security implication of those features, so that you can mitigate them on time before you get to production. Perform end-to-end data flow analysis across your entire software application and infrastructure early and often. It's very, very important. An end-to-end data flow analysis. You need to know how data flow across your deployment environment. Okay, if a user comes, how does that data flow? He enters your web server. From your web server, it hits maybe your backend. From your backend, before it gets to your DB. If you don't understand that flow, you might not know exactly where the loopholes are coming from. So it's very, very cool. It's very, very okay that you have an end-to-end data flow analysis. Embrace infrastructure as a code, just like I mentioned, as a data as a code. Leverage continuous delivery mindset to keep patching and remediation of vulnerabilities. Finding quick and therefore attack window is short. Of course. That's the whole idea, is that you should, just like I mentioned, frequent auditing of your infrastructure, of your security infrastructure. Frequently audit your infrastructure to ensure that there's no vulnerability that you cannot detect on time. So that when you detect it on time, you have more time to actually get it fixed. Take the position of your user when you build. This particular part is very, very important. When we are talking about security, especially when you are carried along at the design stage, you need to think as a user. If I am a user, what are the expectations security-wise I have on this application? It's only when you take that standpoint as a user that you definitely understand how your users will actually react to security threats. Managing customer experience and security in complementary. What I mean by that is that customer experience, for instance, you can say, okay, I want to secure my application, but to the detriment of the experience that the customers, will encounter, you now try to bring in a whole lot of tools, that will make the application usage very slow. So you need to be very, very careful to ensure that you don't, hinder or you don't destroy the customer experience for your application. Keep things simple. As a security expert in DevOps, you break things down into smaller chunks. Don't try to how do I put it now? Don't try to over insert things that will actually destroy or make things very much complex. You need to keep it very simple. Focus on continuous improvement, celebrating wins along the way. Each time you succeed, for instance, what we do in our organization is that almost every 2 weeks, we do a security review of all our infrastructure. We ensure, of course, we have an automated tool that checks all our servers for security vulnerabilities very, very regularly. So each time, almost every month, when we do and we don't encounter any issues, of course, we pat ourselves in the back and say, yes, we have done great and all that. If there's any part that we need to improve on, we work on it as quickly as possible. So focus on continuous improvement, celebrating the wins. So reward your team for doing things correctly. It's very, very important, because the point is that you already have if you have a set of rules that you need all your teams to follow. For instance, you need to do some audit, you need to do this, you need to do that, and all kind of stuff. A way to encourage them is just to ensure that each time they do something right, you pat them in the back and say, guys, well done, so that they can be doing more things for you. So in summary, the goal in security operation responsibility and infrastructure is to secure. To ensure that you don't get hacked. That's just the ultimate goal. Ensure that you don't get hacked. It is not about tools. We should be very, very careful, especially in terms of the tools we use. Or say we want to be using multiple tools just to make sure that our environments are secure. It's not about tools. The end goal is just about making sure that we are very secure and we are not being hacked. So be very careful on the tools you select. It is really not about certifications. Some people like the PCSI and all kind of stuff, certification and all kind of stuff. Some people just focus on, okay, let's just make our environment, certified enough to get the certification. When you get the certification, what happens? So it's not just about the certification. You need to be also, very focused. The end goal is to make sure your environment, even the certification, the purpose of that certification is to ensure that your environment is very secure. It's about the peace of mind and confidence that we are equipped to handle the will-be attackers. If you secure your environment, of course it gives you confidence. It gives you confidence that yes, even when attackers come into my environment and try to hack me and all that, I'm very confident that yes, I can withstand them. But if you don't do your due diligence, if you don't put all these security measures in place, you might regret it later. So avoid the trap of adding tools and time into your increasing complex infrastructure and focus on what really matters. Delivering secure, high-value tools and applications to your user. That's just the ultimate goal. Most of us must have seen this as a DevOps. As a DevOps guy, of course. My focus here is actually on the security tool. The security tool here is actually my focus. In my company, actually, what we use, among those tools here, you can actually choose any of them to use. Or what we use in terms of security is actually, the set of tools we use SonarQube, we use OSSEC, we use Snort in some cases. So these two tools are actually what we use. So you can actually look at them and see how it actually helps you. So SonarQube actually helps you do a whole lot. SonarQube helps you do a whole lot, especially when it comes to integrating it into your development cycle. So this is a typical development cycle in terms of the security. Again, what we'll do is that from the code to commit, to the CI pipeline, to the CD pipeline, at each layer, of course, we have a security measure implementation to ensure that we are secure along the way. So, and the major tool that we actually use here is actually the SonarQube. The SonarQube has, of course, it has the server end and it has what we call the SonarLite. SonarLite can integrate it into your IDE to understand your static code and for your static code analysis. So each time you can actually integrate it into your IDE, and when you do a review of your code, it actually sync the report to your static code and you can review them and fix all vulnerabilities as quickly as possible. It also has a unit testing integration that you can do. So at this point, actually, just as you know, the takeaway I want us to get from this particular discussion is to ensure that our environment is secure by making sure that across all our pipelines and all that, we integrate security at each phase that matters. So if you have any questions, please, we are here to address them.
Should I ask?
Yeah, you can be continuing.
Okay, so one of during his explanation on how he designed to reduce failures, he explained how build-green deployment helps to avoid deploying bad artifacts to disrupt production. So I want to ask, if we have a scenario where the deployment strategy is rolling updates, are we still going to have the same effect where a bad artifact does not disrupt what is already running in production? Did you get the question? Okay, so you mentioned that you explained how build-green deployment helps to avoid deploying bad artifacts to production. So my question is this: if your deployment strategy is rolling updates, are we still going to have the same result where the bad artifact does not disrupt production?
What Facebook does. Let me use Facebook to explain to you. Facebook has two websites. They have facebook.com, they have web.facebook.com. And when Facebook is doing an update, they redirect you to web.facebook.com. Okay? No matter how you type the address on the address bar, you go to web.facebook.com. What are they trying to do? They're trying to run an update on the set of servers that are pointed to facebook.com and have a proxy guide that takes you to web.facebook.com. Until that deployment is done and it is ready and it is certified okay, they redirect traffic back. So what happens is that you start landing on facebook.com. So they do the blueprint both on DNS layer and on the server layer. Okay? Now, there are sometimes you do blueprint also only on the server layer. So the user does not notice any change. I don't know if you are getting me. So what happens
Like the blueprint example. Then secondly, so I don't want to waste your time. Taking a kind of what do you call it? Failover replica. You're trying to have a kind of failover replica. And somehow the failover replica is actually, like for your DSR failover. And maybe in the scenario, you also have a real replica. I don't know. I have such kind of architecture. Yeah, I have a failover replica, you have a real replica. What the real replica does is actually reduce operations that have to do with that less write intensity and move on to real replica. But real replica actually creates entire site. Now, where I have a challenge is in a case where you're trying to do blueprint, and you have this kind of architecture. You understand? Now, and you know that there's a little latency between your real replica and your master. So, how do you manage that and still achieve blueprint?
I think your question is, so when you are blueprint deployment, and that little downtime for you to switch to the other server, how do you handle it, right?
Yeah. So that's why in Blueprint, okay, the funny thing I learned recently is that DNS is very powerful. And we don't value DNS a lot. Very powerful. What happens is that, it takes time for your update to propagate globally. Between the time of propagation, you can do all your gymnastics and wait for your DNS to route over. Your users will never see a downtime. Do you understand? But what happens most time in DNS is that we just switch. We change it to 60 seconds and we save. So what happens is that you are bound to experience a downtime during that process. Now, AWS Route 3 is one of the best DNS globally. It's bound for argument. But let me tell you why. It has this feature out of the box. Okay? There are two features in AWS that helps you with this question. Latency routing and failover routing. With these two features, you can check it out. It can solve this problem for you. So work with your TTL very well. Work with your failover configuration. You will not have a downtime during the switch. Does that answer your question? Alright. And also caching too can help you. There's a lot. Thank you.
Alright, thank you very much. A round of applause for Livy and Ewere. Thank you guys very much.